Okay, today we're going to go over circles. First off, like we talked about last time in class, a circle is the first of the conic sections that we are going to go over. Conic sections are simply curves in a plane that have second degree equations, meaning that we have variables raised to the second power. They are obtained by slicing a double cone with a plane. Okay. Now the set of all points. Okay, we're going to define this circle here. Okay, sorry about that. I had a little interruption here. Circle is a set of all points in a plane that are a fixed distance. And that fixed distance is called the radius. And that distance is away from a fixed point called the center. Okay. An equation of a circle. Again, as I stated last time, a circle will have a center HK. That's an x value of the center and a y value of the center, but we define it as HK. It has a radius named r, and it has the following equation: x minus h, which will be your x value of your center, and all that quantity is squared, plus y minus k, the k being the y value of your center, that quantity squared, is going to be equal to the radius of that circle squared. Okay? Now, if that center of the circle happens to be at the origin, at 0, 0, then the equation would simply be, if we subtract 0, we subtract 0, it would simply be x squared plus y squared equals r squared. Okay? Now, let's talk about a translation of a circle. A translation is simply sliding a graph to a new position on that coordinate plane. And we're going to do that without changing its shape. Okay? So we're simply taking the same circle and we are moving it left, right, up, or down. Okay? Now, when translating, the following rules will apply. The circle will move right if h is positive. Okay? The circle will move left if h is negative. It will move up if k is positive, and it will move down if k is negative. Okay. But remember, if h is positive here, what you're going to see in your equation is minus some number. If h is negative, what you are going to see is you're going to subtract a negative, which would give you a positive. So it actually works opposite. If h is positive, you see a negative. If h is negative, you see a positive, and it works the same way for the k values. Hopefully we'll clear that up in some examples here. Okay, so let's find an equation of a circle with the following properties: a center of 3, -1, and a radius of 2. So just plugging straight into our formulas. Remember, it's x minus h squared plus y minus k squared equals radius squared. So plugging those values in, be x minus 3 squared plus y minus a negative 1, all that quantity squared equals 2 squared. And I've just plugged in for the h, I've plugged in for the k, and I've plugged in for r. Okay, now simplifying, x minus 3 squared plus y plus 1 squared equals 4. Okay. So now over here with these properties, I'm going to have x minus, x minus a negative 2 squared, y minus 0 squared equals 4 squared. So simplifying, I would have x plus 2 quantity squared plus y squared equals 16. And I should be able to, in working backwards, tell that the center of this circle is negative 2, because it should be the opposite of what I see there. Negative 2, 0, with a radius of 4. Same way over here. I should know that the center is positive 3, negative 1, with a radius of 2. Alright. Now let's graph this equation. We need to know a couple things in order to graph it properly, and that is that where the center is. So my center here is at 2, negative 4. Just remember, it's the opposite because my equation has a negative in it. So it's x minus whatever the x value is. It's y minus whatever the y value is. So it's always the opposite of what you see. And the radius is 3. So I would go plot the center at 2, negative 4, 2, 1, 2, 3, 1, 2, about right there. Now, easiest way to graph this then is to move directly up, down, left, and right 3 units. So write 1, 2, call it 3 over here. 1, 2, 3 up here. Let's move this one in a little bit closer to there. 1, 2, 3, about right there, and 1, 2, 3, about right there. Kind of hard to draw a circle here, but I'll do my best. Not bad. Not too bad. Now the other way to graph these is using a translation. My h, I knew up here was 2, and my k was negative 4. Therefore, I would need to move to the right 1, 2, and down 4. So 1, 2, 3, 4. So I moved my center that far. Now I would need to move this one. 1, 2, 1, 2, 3, 4. I'd need to move this one. 1, 2, 1, 2, 3, 4. Move this one. 1, 2, 1, 2, 3, 4. And I'd move this point. 1, 2, 1, 2, 3, 4. About in there. Okay? And you could translate it that way. Let's pretend like that was in there, right? I didn't have my hash marks over here. Okay, so you can graph it directly from here, or you can graph, again, what we call the parent graph, where it would be without any translation, and then move it. that might come in handy as we do some of our further conics down the road here. Okay. Now, if the graph of a given equation is a circle, find its center and radius. If the equation has no graph, say so. Here's what we need to do. It's a simple form of factoring. Oh, not that simple, but I think we can go over it in brief here to jog your memory. We must complete the square. Because as you will note back here, well, let's go here for example. These are perfect squares. If I were to take x minus 2 times x minus 2, that would give me a perfect square trinomial. Okay? If I were to take y plus 4 times y plus 4, gives me a perfect square trinomial, which I can factor into this. So what we're going to do now is kind of work backwards. Okay? So, the first thing is we notice we have an x squared and an x, a y squared and a y. So what I want to do is I want to get those alone and move this over here. So subtract 5 from both sides. Okay, and here's what I will be left with, because I need to fill in the blanks here. I'm going to have x squared plus 6x. And then I'm going to have to add something in there. Okay? And I have a y squared left minus 2y, and I'm going to have to add something to it to be able to make it a perfect square. And this whole thing equals negative 5 now. Okay? Now, the way to figure out what you can put in here to make it a perfect square trinomial is simple. You take this middle number and you divide it by 2, and then you square it. Okay? So, follow along here. X squared plus 6x plus, and I'm going to go ahead and fill out the rest of this. Oh. What I also want to show up here is I'm going to add something and add something, because whatever I do over here, I have to do here. Whatever I do here, I have to do here. Okay? And that will keep us from forgetting. So, divide this coefficient by 2, which will give me 3, and then square it. That'll give me 9. Don't forget to add 9 over here. Now I've got y squared minus 2y plus. Take negative 2, divide it by 2. I get negative 1. I square it. I get a positive 1. Okay? So, now it's just a matter of factoring. This is a perfect square trinomial, which would be x plus 3 times x plus 3, right? This is a perfect square trinomial, which would be y minus 1 times y minus 1. Whoops, I forgot up here. I added 1 here, didn't I? Added 1. Equals negative 5 plus 9 plus 1. So that's a 10 minus 5, which is 5. Okay, so let's write this in the form of a circle. X plus 3 squared plus y minus 1 squared equals 5. And I can go give my final answer now. The center of this circle would be at negative 3, 1. And the radius is this. Remember, r squared would equal 5, right? That's what r squared equals. So I'd take the square root of both sides, so r equals root 5. It can't be plus or minus 5 because r is a distance, right? Radius is a distance. Okay. Now, move on to this one. I have an x squared and an x, a y squared and a y, so I'm going to move this 26 over minus 26 and set it up. X squared minus 4x plus something, y squared plus 8y plus something equals negative 26 plus something plus something. Okay. Well, let's go ahead and fill in these blanks here. Divide that by 2, and then would be negative 2. Negative 2 squared is positive 4. Divide that by 2, that would be 4. 4 squared is 16. So I added a 4 and I added a 16. So let's go down, factor this. This would be x minus 2 times x minus 2, right? So x minus 2 squared. This would be y plus 4 times y plus 4, which would be y plus 4 squared. Now, negative 26 plus 20 would give me a negative 6. You'll be tempted to say that the center is at 2, negative 4. However, can my radius squared, can anything squared be a negative? When I square anything, can I get a negative? That answer would be no. Therefore, we would have no graph here. This is not a circle. Okay. Now, your assignment would be on page 410, and I would like you to do 3 through 30 multiples of 3, and then I would like for you to do 35 through 42 as well. Have a good day.